Hello, this is Eunbi Choi from KAIST AI, and I will talk about our label embedding approach for Chinese Grapheme-to-Phoneme Conversion. In Grapheme-to-Phoneme Conversion task, in other words, G2P task, the input is a word or a sentence, and the output is the corresponding pronunciations. The Chinese G2P system maps the pronunciation, known as pinyin, to every character in a given sentence. In this work, we propose a novel label embedding approach for the Chinese G2P task. In brief, the label embedding approach is to project both input characters and labels into the same vector space, and then choose the dense label embedding closest to the input character embedding. We apply triplet loss to train G2P conversion model with label embedding. Therefore, during training, the embeddings of the input characters and the correct pinyin are getting closer, while the embeddings of the character is moving away from the wrong pinyin's embeddings. Note that these negative samples are not just randomly selected wrong pinyins. Every Chinese character has one or more candidate pinyins, so in our negative sampling strategy, according to the context, candidate pinyins, except for the correct pinyin, are used as negative samples. We devised the label embedding method to utilize information of negative candidate pinyins, which was not used by one-hot label classification models. The architecture of our model is simple. We learn character embeddings with an embedding matrix and an encoder we use by LSTM, and learn pinyin embeddings with an embedding matrix. After that, training is carried out as mentioned before. We use cosine distance to compare the triplet loss. The results show that the label embedding classifier outperformed the one-hot label classifier in all matrices on two Chinese G2P conversion datasets. It achieved 4.5% and 1.7% improvements compared to the one-hot classifier in terms of polyphone disambiguation accuracy. It demonstrates that label embedding with negative sampling significantly improves polyphone disambiguation performance by utilizing candidate pinyins. To sum up, we propose a novel label embedding approach for the Chinese G2P conversion task, and we observe significant improvements in our label embedding approach compared to the one-hot label classification. Thank you.